So this is technically the second video, picking up right where we left off, doing the second half of this practice test, or this review for the actual test. Number 15, it says write each expression in radical form, or write each radical in exponential form. This is really easy. It's like free points on the test. All right. All you have to do is remember that the power of 1/2 is really what? What's the power of 1/2 really? The power of 1/2 is really the square root, guys. So the power of 1/2 is really the square root, and all you have to do is put in the 5xy right in there. Now, why am I putting the whole 5xy right in there? Because the whole thing has a square root. The whole thing is inside the parentheses. Now, let's take a look at number 16. 16 is a little tricky. We do know that the power of 1/2 is a square root. So how am I going to write number 16 as a radical? Am I going to write the square root of 17m? No. What am I going to write? 17 square root of m. Now, some of you are thinking, what? Why not put 17 in there? Remember, m to the 1/2, m is the only thing that has the 1/2 power. The 17 does not have the 1/2 power. Unless you had it all in parentheses, then, yeah, the whole thing goes inside the square root. But right here, it doesn't have parentheses around the 17m. So m is the only thing with the 1/2 power. So m is the only thing inside the square root. And the 17 is just a 17 out in the front. And that's it. So on this section, you don't have to do any math. All you got to do is rewrite it. Let's take a look at number 17. I want to change the radical back to an exponential. So how am I going to change square root of 11y to be an exponent?
You put 11y in parentheses and the square root of 1/2.
There you go. Keywords in parentheses, right? You need in parentheses. If you don't put those parentheses, you're not going to get it right. Okay? Because if you say 11y to the 1/2, that's really saying 11 square root of y. But you need the parentheses in order for it to be included. The 11y is included in the square root, so the 11 and the y have to be included inside the parentheses. Let's move on to number 18. Solve each equation. Now, you need calculators for this, guys. All right? You need a calculator for this. So, it would be nice if this number can be rewritten as what? Now, you see how you have a 5 right here?
Oh.
So you have 5 to the x plus 4. It would be nice if you could make this a 5 to the something, right?
X equals 3.
I don't know yet.
I do.
Okay, so you could also check the answer in the back, right? Now, here's the deal, guys.
Oh, you can?
What number could 78,125 be actually rewritten to? 5 to the 7.
3 plus 4.
Okay, so 5 to the 7 is really 78,125? Yes? Okay, so now that I have the base 5 over here and the base 5 over here, now I could focus in on the exponent x plus 4 and the exponent 7 and create a simple equation, because the 5s are going to just disappear, and I'm going to have a simple equation that says x plus 4 equals 7. And now you could solve that equation by subtracting 4, x equals 3. And that is your answer for number 18. Now, if you wanted to double check, you could take the 3 and plug it in right there and say 3 plus 4 is 7, and then 5 to the 7th power really is 78,125. So these are also pretty easy on the test this Friday. Okay. Let's continue. Number 19. What would it be nice to change this 16,000 number to? Base 4, right? So right here we have 4 to the 3x plus 4, and then it says equals. It would be nice if I could change to a 4 to a certain power. 4 to what power gives me 16,384? Now you could just start guessing. You could say like 4 to the power of 6. If I did 4 to the power of 6, it's 4,000. It's not high enough. So I'm going to try the next one, 4 to the power of 7. 4 to the power of 7 really is 16,384 on a calculator. So I really have, let me erase this right here and rewrite it as just 7. So I really have just 7 right there. And now that I have the base 4 on both sides of the equation, I could just scratch out the bases and I'll have a simple equation, 3x plus 4 equals 7. And of course I could solve that by subtracting 4.
3x equals negative
equals positive 3. So when you divide both sides by 3, we get x equals positive 1. And that is your answer. Let's move on to number 20. Whoa, stuck. Number 20 is fun because you don't really have to do any math. All you have to do is understand what you're looking at. So number 20, they ask you, is this exponential growth or decay? It is growth. How do we know it's growth? The b value, the base is greater than 1. It's not a fraction, it's a number greater than 1. So if you take any number and multiply it by this base 3, it's going to grow. Now if you had a fraction that's less than 1, like 1/2 or like 1/4 or like even 7/8, if you take any number and multiply it by a fraction that's less than 1, then it shrinks, so that would be a decay. So once again, if your base is greater than 1, it's a growth function. If your base is less than 1, a fraction less than 1, then it's a decay function. You guys understand that? So there's definitely growth. But then on top of that, they ask us to do something else. State the domain and range. And we don't even see the graph. But we need to be able to visualize the graph. What does a growth function actually look like when it comes to an xy plane? What does a growth function look like? And what's the asymptote right here? What's the asymptote? 2. So let me actually put a couple of, let me make this xy plane right here. So we know the asymptote is at 2, so it's up here, right? Just a quick sketch so we could understand it better. And what does a growth function look like from left to right? It grows, and it grows up, right? So obviously this graph is not accurate, but it's a sketch, and it's good enough to know what our domain and range is. So what would our domain be? X equals all real numbers. Now how about the range of the sketch? Remember your range.
Y equals.
Not y equals.
No, y is greater than 2.
Greater than 2. Remember your range is always y is either above or below your asymptote value. And since we know it's a growth function, it grows up and it's above that asymptote value of 2, so the range is y is greater than 2. So there's going to be questions like this on the test Friday, so please make sure you understand them. Number 21, identify the following graph, whether it's growth or decay, and state the domain and range. So we always look at lines the way we read sentences from left to right. So from left to right, what's happening? Some people say it's growing, but the question is, does it grow to positive infinity? Does it grow to negative infinity? No, it actually approaches a certain value. That's called decaying to a certain value, right? So it decays to the value of what? 4. Okay? So anyway, this is a decay function. The most common mistake people make is they call this a growth because it looks like it's growing, but it's actually decaying to a certain value. So that's a decay. And it says state the domain and range. Okay, the domain, we already know x equals all real numbers. And the range, it's y is, where is this at? Is it above or below a certain value? It's less than 4, so y is less than positive 4. There's your answer. Decay, domain, range. You're going to have to do that on Friday as well. So please make sure you know how to do that. Number 22, identify if the following graph is growth or decay. What do you guys say about that one? Is that growth or decay? Growth. That's growth. Once again, some people say, oh, it's going down from left to right. That means it's decaying. No, it's not. It's growing in a negative direction. It's kind of like credit card debt, right? If you have a bunch of credit cards, you don't owe any money, that's fine. But then you start charging, you're going to owe a lot of money. It's growing in a negative direction. So this is definitely growth. Let's label that. And now we need to state the domain and also the range. Domain, x equals all real numbers. Range is what? Y is it above the asymptote or below the asymptote? Below the asymptote. What is the asymptote?
Y is greater than...
Not below, not above. Less than negative 1. Now see this asymptote value right here? It's at negative 1. And the whole graph is below negative 1. So those are a couple of easy questions. All you got to do is practice, and you'll do fine on those. Let's move on to the next page so you can flip it over. Now, this is an open response part, and there is an open response part of the test. So, by the way, these instructions are from the test generator. It says at least 2 points. I want a bunch of points, all right? I don't want just 2 points. I want more than 2 points. So let's graph, and remember, whether it's growth or decay, I gave you certain steps on how to graph. I say ignore the H and the K, box in this part, and we make an XY table with consecutive integer inputs like -3, -2, -1, 0, 1, 2, 3. Now maybe we're not going to use all these, but we're going to use a couple of them. At least 2. It says at least 2. Let's use like 2 or 3, or as many that fit nicely on this graph. So let's start with the easiest one. If I plug in, which is the easiest number to plug in? 0. Plug in 0 right there. What's 1/3 to the 0 power? 1. This whole thing is 1. And then 1 times -3, the output will be -3. So when I plug in 0, I get out a -3. Now remember, these are coordinates to the parent graph. At the end of it all, once I have all of my coordinates, I'm going to shift them 2 units up. Okay? So anyway, let's find the rest of these. Now I could plug in a 1 and work out the math, or I could plug in a 2, work out the math, plug in a -3, work out the math. Or the easier thing to do is to look at my output, -3, and simply take this. Is this a growth factor or a decay factor? It's a decay factor. I want to decay this 3 by this decay factor of 1/3. So if I take -3 and multiply it by 1/3, if I take -3 and multiply it by 1/3, what do I get on my next output? What is -3 times 1/3? -1. And then if I were to take -1 and multiply it by 1/3 again, what do I get? -1/3. And then if I were to take -1/3 and multiply it by 1/3 again, what's -1/3 times 1/3? -1/9, because 3 times 3 is 9. So we have -1/9. And it's already clear to me that it's getting smaller and smaller and smaller, closer and closer to 0, right? But let's find some coordinates in the opposite direction. So if I'm actually multiplying by 1/3, it's like dividing by 3, dividing by 3, dividing by 3. Going backwards, it's like multiplying by 3, multiplying by 3. And right here, it's really clear. -1 times 3 is -3. And then -3 times 3 is what? -9, right? And of course, I don't need to do the next one. The next one's -27. So that's ridiculous. It's already off the graph. So yeah, we need at least 2 points. I would like to see more than that. Let me graph this right here. So -1, -9. Oh man, this graph is even too small for -1, -9. So if I go 0, -3, that's right here. If I go 1, -1, that's right here. If I go 2, -1/3, that's right here. If I go 3, -1/9, that's really close to nothing. If I did go -1, -9, it would be way down here somewhere, right? If I went -1, -9, yeah. But anyway, I know that from left to right, it's decaying to 0. It's decaying to 0. So this is my parent graph. And you could even draw other points that are closer. That's my parent graph. My asymptote on the parent graph is y = 0. So from here, what I need to do is shift it where? Where do I move this parent graph to? 2 up. So I need to take all my coordinates, and in reality, yeah, only 2 significant coordinates get moved up. This coordinate gets moved up, because this one, if I move it up 2, it's still going to be off the graph. This one, move it up 2, it'll be right there. I want to change colors. Take the next one, move it up 2, it'll be right there. And then you take the asymptote that used to be right here, move it up 2 units, it's going to end up over here. Make sense? So I guess these instructions, I guess they do make sense. It says use 2 points at least. We have 1 point here that we moved up and 1 point here. And the asymptote, just connect them and you'll be good. So that's the graph. And then it says state the domain and range. Okay, what's the domain of that blue one? X equals what? All real numbers. The range, the y value is less than 2. That's right, because the whole blue equation is all below this y value of 2. The asymptote is 2. Oh, it says state the asymptote as well. Okay, so you go y equals 2. You want to write it as an equation. Let's try the next one. Number 24. Is this a growth or a decay function? Decay. This is probably one of the easiest ones because there is no k-shift. So what you graph, your parent graph, that'll be it. Okay? So let's make an xy table. And let's plug in consecutive integer inputs. -3, -2, -1, 0, 1, 2, 3. Let's plug in the easiest number, 0. And when I plug in 0, I get out what? 1. And then, instead of plugging in the rest, I'm going to say that my decay factor is 1/2. So I'm going to take 1 and I'm going to decay it by 1/2 to get to the next one. So what is 1 times 1/2? 1/2. That's right, 1/2. And then what's 1/2 times 1/2? 1/4. And then 1/4 times 1/2? 1/8. And we know it keeps getting smaller and smaller, infinitely approaching 0. Going backwards, it would be multiplying by 2. So if I take that 1, and on the way up, if I take this 1 and multiply it by 2, what do I get as the next output up? 2. And then the next one up? 4. And then the next one up? 8. Okay, now again, these graphs are smaller, so we're only going to be able to use a couple of these points. So let's graph -2, 4. -2 on the x, 4 on the y, there it is. Let's graph -1, 2. -1, 2, there it is. Let's graph 0, 1. There it is, the y-intercept. Let's graph 1, 1/2. 1 on the x halfway up is right here. And then 2 and 1/4, that's half of the half. So 2 on the x, half of the half. And then the next one, 3, and then 1/8, it's even smaller. At this point, I can't even really draw the difference between 1/8 and 1/4. It kind of looks the same. Or especially 1/8 and 1/16. 1/16 looks like that. 1/32, it looks like that. Whatever, I can't draw the difference. Now, I don't have to shift these up or down because there is no k value. If I did ask you for the asymptote, which I do, what is the asymptote?
0.
As an equation?
Y equals 0.
Y equals 0, that's right. So I'm going to draw this guy. That's my exponential decay function. What about the domain and range?
X equals 0.
And the range?
Y is greater than 0.
Y is greater than 0 because the whole blue equation is above the x-axis, which is the y value of 0, which is the asymptote. Last one here. Is this a growth or a decay function? Growth. Let's make an xy table. Let's ignore the k value. So again, when I say ignore the k value, I like to box in what I'm going to be looking at and not the k value of -4. So if I do plug in 0 right in there, 3 to the 0 is 1. And then after that, I'm going to use the growth factor of 3, right? The growth factor is 3. The base is 3, so it's going to grow by 3. So what's the next output going to be? 3, because 1 times 3 is 3. And the next one? 9. And the next one? 27. But see, these already are off the graph, so I'm not going to be able to use those. And then going backwards, it'd be dividing by 3. What's 1 divided by 3? 1/3. And at that point, I could already stop because the next one, 1/9, it's so close to 0, I'm not even going to be able to tell the difference. So yeah, we're only graphing a couple of these. So remember, this is the parent graph. Let's graph what we can here. Let's do the coordinate 0, 1. That's the easiest one to do. That's right there. This is the parent graph, though. Then we'll do 1, 3. 1 on the x, 3 on the y. It's right there. If I did go 2 and 9, it's going to be way up there, probably even further up. Okay? And as I go to -1 and 1/3, that would be -1 and then 1/3 of the way up. It's not even halfway up. So let me draw it right here. It's not even halfway up. And -2 and 1/9, that's almost nothing. You can't even tell the difference anymore. I'm just going to draw dots right on the x-axis. But this is the parent graph. What do I need to do to the actual graph or to these coordinates to get the actual? Bring it down how many units? 4. So if my asymptote on the parent graph was right here, I need to bring it down 4 units, and my asymptote will be right here. Make sense? Okay, now let's bring down a couple of more points. Now, it's pointless to bring down these points that were on the close to the asymptote. Let's bring down this guy, 4 units, 1, 2, 3, 4. Put a dot right here at 0, -3. And then let's bring down the other one, 1, 2, 3, 4. It's right there. So connect those dots, put an arrow on it, you're done. Final thing, what was the asymptote? Y equals -4. What's the domain? All real numbers. How about the range? Y is greater than -4. We got it. So this is one practice test. I will give you another practice test tomorrow. There's 2 videos on this practice test. Make sure you understand the whole thing.